What's up? I'm Vin, and today I want to take a look at arithmetic sequences. So here's the definition for arithmetic sequence, and the nth term can be found using this formula. But let's just jump into a few examples. So let's take a look at a few examples where we just have to determine if the sequence that we're looking at is arithmetic. And let's say I start with, we have 11, 17, 23, 29, and this continues. So we want to say if this is arithmetic, and if it is, we're going to find the common difference. And the common difference is just the amount that it's going up by each time. So when I look from here to here, the first thing I notice that this is jumping up by 6. And then from 17 to 23, this is jumping up by 6. And then from 23 to 29 is also jumping up by 6. So I would say that yes, this sequence is arithmetic, and the common difference here is equal to 6. And we're basing it on just the terms here that are listed. So we'll look at another example here. Let's say I have 1/2, I have 1/3, 1/4, 1/5, and the list continues in this pattern. Well, the denominators are all jumping up by 1, but the numerators are remaining the same. So right away I'm looking at this and saying, no, I'm not adding the same amount each time if only the denominators are increasing by 1. So my first idea is that this is a no, but if I want to be 100% precise, I subtract any two consecutive terms. Let's say I subtract 1/3 and 1/2. Well, I find common denominators, and this I could write as 2/6 minus 3/6, which is -1/6. But then if I do this again for the next two consecutive terms, let's say we first did 1/2 and 1/3, so now we'll do 1/3 and 1/4. So if I subtract those two, notice here if I find common denominators, I'll have 3/12 minus 4/12, which is -1/12. So right away I could say no, because the difference here was -1/6 and the difference here was -1/12, and we could just say there is no common difference. So this is our rationale for why this sequence here is not an arithmetic sequence. So we'll move on here, and I want to look at another example. Let's say this time around we have 16, and then we'll look at, we have 9 next, we have 2, we have -4. And you have to be very careful with these questions, because you might notice from here to here, this is decreasing by 7, but then there's like a little sneak attack here. If you just assume it's always decreasing by 7, and you don't check the last one, notice that this last one decreases by 6. So here, we could just say, once again, is this sequence arithmetic? We could say no, because there is no common difference. So we'll look at one more, and this last one that we'll take a look at here is probably the sneakiest. And let's say we just look at these terms here. We have natural log of 2, natural log of 4, natural log of 8, and then natural log of 16. And at first glance, some people, if they're not careful, might say that this is going to be a no. But in this case, this is actually going to be an arithmetic sequence, because if I subtract the first two consecutive terms, natural log 4 minus natural log 2, if I use property of logs, I could combine this subtraction into a single log by division, and I'll have natural log of 4 divided by 2, which is natural log of 2. And if I subtract the next two consecutive ones, natural log of 8 minus natural log of 4, I use the division property again, and I also get natural log of 2. So by now, I'm pretty convinced that this is going to be a yes, but just to be certain, I'm going to see what happens if I add natural log 2 to natural log of 8, because right now I'm saying yes, and the common difference is natural log of 2. But if I add the common difference to natural log 8, I could use the multiplication property, combine those two logs by multiplication, and that's going to give me the next term, which is natural log of 16. So this is going to check out as our common difference. So now let's take a look at a different kind of example. Let's say we want to find the common difference, the first 5 terms, the nth term, and the 300th term of this arithmetic sequence here. So the first thing I'm going to look for is the common difference. And I'm noticing right away that this sequence decreases by 6 each time. And you could see here that, once again, each time I just do 1 minus 6 to get to -5. I could do 7 minus 6 to get to 1. So d equals -6 definitely checks out. So what we also have to identify in our formula, we have a plus n minus 1 times d. the common difference we just found, but we also have to identify a, which is the first term. So I could say here that a is equal to 13. So to find the first 5 terms, that I don't need a formula for. We could just continue this list. So the pattern is subtract 6, and negative 5 minus 6 is negative 11. So I could stop here for this part, and that checks off finding the first 5 terms. Now to find the nth term, what I want to do is I'm going to just plug into this formula. A is equal to 13 plus we have n minus 1 times d is negative 6. So I could leave it like this, or I could say the nth term is 13 minus 6 times parentheses n minus 1. So then from here, the last thing I want to do is find the 300th term. So I'm going to use this formula that we just made here to find our 300th term. So a sub 300 is just going to be equal to 13 minus 6 times 300 minus 1 is 299. Okay, so this here we could just punch into a calculator, and this is going to work out to minus 1781. So this is going to be our 300th term. So this last question is really nice. We have the 11th term of an arithmetic sequence is 52, and the 19th term is 92, and we want to find the 1000th term. So here I could say a sub 11 equals 52, and I could say a sub 19 is equal to 92. And the general formula for any arithmetic sequence is a plus, and we have n minus 1 times d. So what we want to go with here is the idea that a sub 11 corresponds to n equals 11, and this corresponds to n equals 19. And we could plug that into the general formula here, that at n equals 11, we would have a plus, and we have 11 minus 1 is 10 times d. So this would represent like the general formula for n equals 11. And if we apply the general formula for n equals 19, we would have a plus 19 minus 1 is 18. So we have 18d. But now what I want to do here is I want to write these as separate equations. I'm going to say a plus 18d equals 92, and I'm going to say a plus 10d is equal to 52. And this is a system of equations, and I'm just going to subtract the bottom equation from the top equation. A minus a is just going to cancel out, and then 18d minus 10d is equal to 8d, and then I just do 92 minus 52, which is going to be equal to 40. So that tells us if we divide by 8, that the common difference is equal to 5. So we really need this piece of information here, but what we're going to do is we could take any one of these equations and plug in d equals 5 to solve for a. So let's say I take 52 equals a plus 10 times d, but we just found that d is equal to 5. So this is going to give us 52 equals a plus 50, which tells us that a is equal to 2. So now that we solved for a and we solved for d, what this tells us now is that we could find a general formula. We could say that a sub n is equal to a, which is 2, plus n minus 1 times the common difference, which is 5. So if the goal here is to solve for the 1000th term, we have a sub 1000 is equal to 2 plus 1000 minus 1 is 999, and then this is times 5. So we could use a calculator for this. A nice sneaky little bit of math is you could do 5 times 1000 is 5000, but then just subtract 5 because we're only at 999. So now we have 4995 plus 2, which is 4997. So this is our 1000th term. And just to be 100% clear that we did this right, one thing you could do just to feel safe is you could plug in, let's say, n equals 11 to this formula. And if you did 2 plus 11 minus 1 is 10 times 5, 2 plus 50 gives you 52. And it also checks out if you plug in n equals 19. So I'm very confident here that this is definitely our answer. Okay, well, this is going to conclude this video on arithmetic sequences. If this video was helpful, please like and subscribe. It really helps me grow the channel. And if you got any requests, just leave the topics you want me to cover in the comment section below. And thanks for watching.